Hey guys, welcome back. In this video, we're going to take a look at angles, the unit circle, and then we'll start to talk about special triangles and their role in identifying points on the unit circle. Okay, so to start off today, we'll talk a little bit about angles. We've worked with angles a lot in geometry. Angles are a measurement between two rays. You have two rays here and here, for example, and the angle is this measurement in between. We can call it theta in this case, and we're measuring how far we've rotated in a way between these two rays. The ray we start at is called the initial side of the angle, and the ray that we end at is the terminal side. And then we're going to be working a lot with angles in the coordinate plane. So in the coordinate plane, our angles are almost always going to start on the x-axis. So we'll start here, and then we'll be looking at an angle starting at the x-axis. And angles where we start at the positive x-axis, that's called standard position. So we'll be working with a lot of angles in standard position. We're starting with the positive x-axis and then rotating counterclockwise around the coordinate plane. Okay, so we've worked a lot with angles before. We are now going to take a look at the unit circle. So the unit circle is just a circle with a radius of 1. So here's the unit circle in a coordinate plane. You can see all of these points on the axes is just 1, 0, 0, 1, and so on. We're going to be working with the unit circle quite a bit. And what we're going to be doing with the unit circle is we're going to be looking at points on the unit circle and see how they correspond to the angle to get that point. So here we have a point on the unit circle. Here we have an angle theta. And we're going to be looking a lot at how x and y relates to theta. In other words, when we have an angle, where does that terminal side pass through or intersect the unit circle? So you might ask here, how do we find this point xy on the unit circle? And the process involves drawing a right triangle. So as you can see, we have two side lengths here, or sides of the triangle, the legs, a right angle here, and then the hypotenuse we know is the radius of the unit circle, which is just 1. So now we're looking at how can we relate theta with those side lengths. Thinking back to geometry, we can use SOHCAHTOA to help us out. In other words, trig ratios. So we know that sine of theta equals opposite over hypotenuse. We know the hypotenuse is just 1 in this case. And then the opposite side we can see here is the y value of our coordinate up and down. So sine of theta is equal to y. So if we're given theta, we can find the y value of that coordinate by taking the sine of theta. Similarly, cosine of theta is adjacent over the hypotenuse. Adjacent. And here the hypotenuse is still 1. Which means that the cosine of theta is this side length down here. In other words, x. So we can use sine and cosine to find the y and the x values of this point. If we're interested with tangent of theta, given the x and y values, so if we're given a point on the unit circle and we're asked for the angle that intersects through this point, what is the tangent of that angle? What we can do is think about tangent as sine of theta over cosine of theta. And this is true because tangent of theta using our trig ratios is equal to opposite over adjacent. And if we have sine of theta over cosine theta, we end up with opposite over adjacent because sine of theta is opposite over hypotenuse. And then cosine of theta is adjacent over hypotenuse. So what happens is we are dividing by a fraction. So we're multiplying by the reciprocal. And we end up with opposite over adjacent. So here we can see this ratio, sine theta over cosine theta, is equal to tangent of theta. In other words, tangent of theta, we can take we know sine is y, So tangent of theta is equal to y. And we divide by cosine of theta, which we found out was x. So given the xy coordinates, we can just take our y value, divide by x, and that is our tangent of theta. In other words, the tangent of the angle that has a terminal side going through that point on the unit circle. Okay, theta can be written in degrees. Theta can also be written in radians. And as a reminder, a radian is just how far around the circle we're going. One full rotation around the circle is going to be 2 pi, and 1/2 rotation is pi. Okay, next up, we're going to be working a lot with these special points on the unit circle. So there are specific angles we're really interested in, and that's angles at 30 degrees, 45 degrees, and 60 degrees. So we already know all of the points on the axis. We just have 1, 0, 0, 1. And so what we can do is start off with 30 degrees here, 30 degrees. And we're trying to find what point does this terminal side intersect the circle at. So again, what we can do is draw a right triangle. So 30 degrees in one corner. Up here, we know we have 60 degrees because the sum is 180. And we know the hypotenuse is 1. And this is actually a 30, 60, 90 triangle. This is one of our special triangles. Because if we have a 30, 60, 90 triangle, then we know the side lengths already. We can relate them to each other. So in this case, the side lengths are going to be, if our hypotenuse is 1, then our side length over here is going to be 1/2. And our side length down here is going to be the square root of 3 over 2. So translating that to our right triangle over here, we can see that the y value is 1/2, and the x value is root 3 over 2. In other words, the point here on our unit circle is root 3 over 2, comma 1/2. So similarly here, we're looking at a 45-degree triangle with an angle of 45 degrees in standard position. So here we have 45 degrees. Here we also know is also 45 degrees. Again, this is a special triangle, 45, 45, 90. And the pattern we see here, if we have a hypotenuse of 1, then each side is going to be the same measurement because this is an isosceles triangle. And that measurement is going to be the square root of 2 over 2. And here what we can do is actually use the Pythagorean theorem because the sides are the same, so we can set them both equal to some value like a, and then a squared plus a squared equals 1, and then solve from there. So this point up here, if the x coordinate left and right is root 2 over 2, and here the y coordinate up and down is also root 2 over 2. Up here we have a 60-degree right triangle, so here our angle is 60 degrees. And what we can just do is use this same 30, 60, 90 triangle, but rotate it a little bit. So 60, now 30 degrees is up here in the top corner. We have a right angle, hypotenuse still of 1, and then we just switch the sides. So on the bottom here we have 1/2, and on the right side we have square root of 3 over 2. So it's basically going to be our coordinates over here, but switched. 1/2, comma, square root of 3 over 2. So we use special triangles to find these coordinates. These coordinates are really important because we're going to be looking at sine, cosine, tangent, and other trig values of 30, 60, 30 degrees, 60 degrees, and 45 degrees, and also multiples of those. So if we were looking at 120 degrees, what's happening here is we have a special point that's been kind of like reflected across the y-axis. So here the x value is negative 1/2, and the y value remains the same, root 3 over 2. And it's the same for all of those points. Here we have negative for x, root 2 over 2, comma, root 2 over 2. And then negative root 3 over 2, comma 1/2. Down here, we just switch both of the x and y coordinates to be negative. And then down here in this quadrant, our fourth quadrant, we have positive x values, and then we just make the y values negative. And then the pattern continues using these values. So the key values we're looking at is 1/2, root 2 over 2, and root 3 over 2. And if it helps, you could also think of it as root 1 over 2. Root 1 is just 1. So square root of 1 over 2, square root of 2 over 2, square root of 3 over 2. Memorizing these values is going to make it a lot easier to quickly do math and to quickly work through problems that involve trigonometry. So you can always look up the unit circle and these special values, but memorizing it is going to be a lot faster in the future. So it is important that we know these values. Okay, so here in this video, we introduced the unit circle. We talked a little bit about angles, and then we talked about special triangles and how to find these special points around the unit circle.